Hello. In this video, we're going to get started with FreeCodeCamp's front-end libraries course on React. So React is a JavaScript framework that is very popular, and some prerequisite knowledge for this course is going to be basic HTML and CSS web fundamentals. So if you go to freecodecamp.org/learn, if you follow their learning path and you get the responsive web design certification and then the JavaScript data structures and algorithm certification, you'll be pretty well set up to get into the front-end libraries where the React course is going to be. Those are, really helpful and pretty fundamental, but if you're trying to catch up for some missing knowledge, you might consider sort of like a crash course of like a YouTube crash course and code along with it, or if you aren't able to, just at least view the videos in some free time. So here's an example. I haven't watched this entire course, but this is by NetNinja, who is a popular YouTuber, and this is an HTML CSS crash course playlist that is about a little less than 5 hours total, and then this is a modern JavaScript crash course that's a little less than 5 hours total. So under 10 hours, you could get through kind of a lot of the basic prerequisite knowledge to get started with React. You can choose not to do that, but I will say it's going to make it more challenging to understand React if you don't have those fundamentals down, and it's going to be hard to delineate in your mind which things that you're looking at are React specific and which are just more generic to the web in general. So with that said, we're going to go to the front-end development libraries step in FreeCodeCamp and then click on the React course to get started. So there's 47 steps here, and there doesn't seem to be any certification in here, but there may be a certification associated with this once you complete all the front-end library courses. So let's see what's first. First, we can also read this. React is a popular JavaScript library for building reusable, component-driven user interfaces for web pages or applications. It combines HTML with JavaScript functionality into its own markup called JSX. React also makes it easy to manage the flow of data throughout the application. In this course, you will learn how to create different React components, manage data in the form of state props, use different lifecycle methods like didComponent, didMount, and much more. React is an open source Vue library created and maintained by Facebook, owned by Meta. It's a great tool to render the UI of modern web apps. React uses syntax extension of JavaScript called JSX that allows you to write HTML directly within JavaScript, or more specifically within JSX. This has several benefits. It lets you use the full programmatic power of JavaScript within HTML and helps you to keep your code readable. For the most part, JSX is similar to the HTML that you've already learned. However, there are a few key differences that will be covered throughout these challenges. For instance, because JSX is a syntactic extension of JavaScript, you can actually write JavaScript directly within JSX. This is important, but you can't write JSX within any JavaScript. To do this, you'll simply include the code you want to be treated as JavaScript within curly braces. Keep in mind, since it's used in several future challenges. However, because JSX is not JavaScript, JSX must be compiled into JavaScript. The transpiler Babel is a popular tool for this process. For your convenience, it's already added behind the scenes for these challenges. If you happen to write syntactically invalid JSX, you'll see the first test in these challenges fail. It's worth noting that under the hood, the challenges are calling React DOM.render JSX, document.getElementById root. This function call is what places your JSX into React's own lightweight representation of the DOM. React then uses, DOM stands for Document Object Model, by the way. React then uses snapshots of its own DOM to optimize updating only specific parts of the actual DOM. The current code uses JSX to assign div element to the constant JSX. Replace div with an h1 element and add the text hello JSX inside of it. So they're saying to make this an h1 tag. You see there's no quotes. It doesn't have to be a string because this HTML syntax is valid JSX. So this is getting turned into an object, a JavaScript object. The last challenge was a simple example, but we can have more complex HTML. An important thing to know is JSX must return a single element. This one parent element would wrap all the other levels. For instance, several JSX siblings with no parent wrapper will not transpile. Here is an example. This is valid JSX because there's a div wrapping all these paragraphs, but this is invalid JSX because there is nothing wrapping it. And there's also actually something called a fragment, a React fragment, which is denoted by this empty syntax here. Or you can also call a function like react.fragment to create one of these elements and then enclose all of your contents inside of it so that they can be rendered as direct children of whatever the parent is. But if that's confusing to you, don't worry about it. Just know that you can't simply return a bunch of elements. You have to return one element, even if it has other things inside. Define a new constant JSX that renders a div which contains the following elements in order: an H1, a P, and an unordered list that contains 3 LIs. So they say we want to have a div const JSX, and it's going to be equal to a div in which there is an H1, a P, and an unordered list. So that would be a UL and inside of here we're going to have some list items, 3 list items to be specific. And if this is not familiar to you, it's probably because you don't know basic HTML, which is what I'm writing right now. When rendering multiple elements, you can wrap them on parentheses, but it's not strictly required. So they're saying you could do this. I'm highlighting this and I'm hitting Shift 9, which is the open paren, and it's going to wrap all of that in parentheses. So this is allowed. Also notice that the challenge uses a div tag to wrap all the child elements within a single parent. If you remove the div, the JSX will no longer transpile. Keep this in mind. JSX is a syntax that gets compiled into valid JavaScript. Sometimes for readability, you might need to add comments to your code. Like most languages, it has its own way to do this. So to put them inside, you need normal JavaScript multi-line comments, but you need it surrounded in curly braces to comment the text. The code editor has JSX similar to what you created. Add a comment somewhere in the div without modifying the existing H1 or P elements. So if I just put my cursor on this line and do Control // I'm going to get a valid JavaScript comment. So what they want us to do, though, is to make curly braces and then to have inside of there a JavaScript multi-line comment like this. Side of the div. And so either of these should be valid. Multi-line comment, SL comment, single line comment. Oh, no, that's not valid. So yeah, I would actually, some editors will probably add the correct bracket syntax for you, but you'll actually need to add, you'll actually need to do your comments like this, regardless of whether it's single or double line. And now that's not showing. So the code editor is similar. Yeah, we know that. So far, you've learned that JSX is a convenient tool to write readable HTML within JavaScript. With React, we can render this JSX directly to the HTML DOM using React's rendering API known as React DOM. React DOM offers a simple method to render React elements to the DOM, which looks like this: React DOM.render, the component to render, comma, the target node, where the first argument is the React element or component, and the second is the DOM node. So that would just be a basic HTML element represented programmatically in JavaScript, like when you do document.getElementById, that returns a normal JavaScript representation of the DOM element. As you would expect, React DOM render must be called after the JSX declarations, just like how you must declare variables before using them. So yeah, this is it's JavaScript-like, so scripts run from top to bottom, so the things that are above inform the things that come below. The code editor has a simple component. Use the render method to render to the page. You can pass JSX directly as the first argument, and we'll need to get the div with the ID challenge node for us to render inside of. So we could also do this in two steps. Const node equals, or we'll say L for element, equals document dot get element by ID, and because it has this ID, we can give that. We don't even need to know that it's a div. It's nice to know, but not necessary to know. And then we'll call React DOM.render to pass in JSX, the template for the React component, and then the element in which we want to put that React. There we go. Now that you're getting comfortable with JSX, you may be wondering how it differs from HTML. So far they seem the same. One key difference is that we no longer use the class word to define HTML classes. It's because class is reserved in JavaScript. Instead, JSX uses class name. In fact, the naming convention for all HTML attributes and event references on JSX become camel case, where that means the first word is lowercase and all subsequent words have the first letter capitalized in what's called title case. For example, a click event in JSX is on click instead of on click, where the C is capitalized in the JSX one, whereas it's not in the JS version or the HTML version. Likewise, onChange becomes onChange with a capital C. This subtle difference is important to keep in mind. Apply a class of myDiv to the div provided. So here, normally in HTML, we would say class equals, and then some name, some class name in quotes, or multiple class names separated by spaces. But instead, we have to use class name because class is reserved here. JavaScript uses the word class. So this class would be fine in HTML, but because this is JavaScript-y, we need to reserve the word class. Oops, and oh yeah, it said add a class to this div, so the div, not the h1. So far, we've seen how JSX differs from HTML in a key way with the use of class name versus class for defining HTML classes. Another important way in which JSX differs from HTML is in the idea of self-closing tags. In HTML, almost all tags have both an opening and closing tag. The closing tag is always having a / before the tag name that you are closing. However, there are special instances in HTML called void elements, or elements that don't require both opening and closing. For example, the line break can be written as BR or BR with a / inside of it, but should never be written as BR with a closing and end tag because it doesn't contain any content. In JSX, the rules are a little different. Any JSX can be written with self-closing tag, and any element must be closed. Every element must be closed. The line break tag, for example, must always be written as BR with a / inside in order for it to be valid JSX that can be transpiled. A div, on the other hand, could be written as a void style div or a div with a opening and closing tag. The difference is that the first syntax, there's no way to include anything in the div. You'll see that in later challenges this is useful when rendering React components. And what they're saying here is sort of true. There's no way to put anything inside, like between these two div tags, but actually there is a way to pass in what are called children to this, which are the components or the elements that you put between the div tags. There's actually another secret way that you can pass things, but they aren't going to tell you about that yet. So to fix the errors in the code, we just need to change the closing tags where they're needed. So right here we have, I guess it wants us to have /HR, is that what they're saying? I think so. And the BR should always be written as a self-closing tag like that. I think that's what they meant. Yep, looks good. My component is a function now. Components are the core of React. Everything in React is a component, and here you will learn how to create one. There are two ways to create a component in React. The first is to use the JavaScript function. Defining a component in this way creates a stateless functional component. The concept of state in an application will be covered in later challenges. For now, think of a stateless component as one that can receive data and render it, but does not manage or track changes to that data. We'll cover the second way React component can be made in the next challenge. To create a component with a function, you'll simply write a JS function that returns either JSX or null. One important thing to note is that React requires your function name to begin with a capital letter. Here's an example of a stateless functional component that assigns an HTML class in JSX. So it's called demo component. It's declared as a const with demo being capital D, and then it's a function which returns some valid JSX that looks a lot like HTML, but it has class name instead of class. So after being transpiled, the div will have a CSS class of custom class. Because JSX component represents HTML, you could put several components together to make more complex HTML pages. This is one of the key advantages of the component architecture React provides. Yeah, and another thing, what I really like about React is because you can render HTML inside of other HTML by nesting components, you don't have to have this super long HTML file. You can have tiny files that are only 10 or 20 lines long, and then just stitch them together into something much larger. React allows you to compose your UI from many separate isolated components. Yep, so they're pointing out that this makes it easier to build and maintain complex interfaces. The code editor has my component complete the function so it returns a div which contains some string of text. The text is considered a child, so you will not be able to use a self-closing tag. Yep, and so what they're saying is they want us to return a div with a closing tag div, and inside of that they want us to put some text, any text, and that seems to work. I think there's also another way you could do this, like return div children equals some text, and it's a self-closing tag. And yep, they don't want you to know this yet because they haven't taught it to you, but that is also another way because we're passing in the children with a self-closing tag, but they want us to do that way. The other way to define a React component was with the ES6 class syntax. So I'm going to point out this is more of an old way to do things, so they're teaching it to you because you may have to maintain other people's class components, and some people love class components. I personally almost never use these. In the following example, kitten extends react.component. So a kitten extends react.component. We made up kitten, but react.component is something that we would have needed to import or have in scope. This creates an ES6 class. ES6 means ECMAScript 6, which is the non-trademarked version of saying JavaScript. And it extends the component class so we can have access to React features like local state and lifecycle hooks. Don't worry if these seem confusing because they'll be covered. Notice kitten has a constructor that calls super and uses super to call the constructor of the parent class, in this case React.component. So if this is all seeming confusing to you, what is constructor, what is super, you might need to brush up on object-oriented programming. This is a fundamental feature of many programming languages, including JavaScript, including Python, including Java, C++. The constructor is a special method used during the initialization of objects that are created with the class keyword. It's best practice to call this constructor with super and pass props to both. This makes sure that the component is initialized properly. For now, know that it's standard for this code to be included. Soon you'll see other uses for the constructor as well as props. And I believe props is short for properties. You know, the funny thing, I always see this and my mind automatically goes to like props for a play, like there's some set of puppets. I even have taught students where they've said, I gotta prop up my component, like lifting something over your head, like I gotta prop it up, you know. So this can get confusing, but it's essentially short for properties, I believe. My component is defined in the code editor using class syntax. Finish writing the render method so it returns a div element that contains h1 with hello react. So now we're nesting, we're doing double nesting. So we are returning. So see, render is the way render is defined here. This is a class method. So when we have an instance of the class, an instance of my component, we could say, you know, lowercase c component dot render, and we would get this result. Return div /div h1 /h1. Now we'll look at how we can compose multiple React components together. Imagine you're building an app and have created 3 components, navbar, dashboard, and footer. To compose those, you could create an app parent component which renders the 3 as children. To render as a child, include the component name as custom HTML in JSX. For example, render, you could write app with inside navbar beside dashboard beside footer. When React encounters a custom HTML tag that it references another component, like wrapped in the left caret / right caret in this example, it renders the markup for that component in the location of the tag. This should illustrate the parent-child relationship between the app component. Yeah, this is a lot of words. It just means app is the parent of navbar, dashboard, and footer. In the code editor, there's a simple functional component and a class component. Compose the two together by rendering the child component within the parent component. Make sure to close the child component tag with a /. We're defining child component with an ES6 arrow function because this is a very common practice. So yeah, instead of using the function keyword here, we're defining a const child component, which is equal to an arrow function, meaning an anonymous function, a function that has no name. This part has no name, but we're assigning this name to it right here. And we want to change the code below this so that it, let's make this a little bigger. We're going to change the code so that the parent component contains the child component. And so what they mean is on the same level as h1, you see we're inside the div, they want us to place child component with a self-closing tag like that. And notice this is a capital C, so that can be helpful to help us tell between HTML elements and React components. The last challenge showed a simple way to compose 2 components, but there are many different ways you can compose components with React. Component composition is one of React's most powerful features, and when you work with React, it's important to think about your UI in terms of components like the app in the last challenge. If you break down a UI into its building blocks, those pieces become components. This separates the code responsible for UI from logic. It can greatly simplify development and maintenance in complex projects. There are 2 functional components defined in the code editor, types of fruit and fruits. Take types of fruits and compose it or nest it within the fruits. Then take the fruits component and nest it within the types of food. So we have types of fruit. We want to nest this into here, and then we want to nest this other one inside of this one. So we've got lots of nesting going on. We're putting types of fruit inside of fruits, and then we're putting fruits inside of types of food. As the challenges continue to use more complex compositions with React components and JSX, there's one important point to note. Rendering ES6 style class components within other components is no different from rendering the simple components you used in the last few challenges. You can render JSX elements, stateless functional components, and ES6 class components within other components. It's a lot of words, but I think they're just saying you can use any type of component you like, class or function, and compose them in each other. In the code editor, types of food is already rendering the vegetables component. There's also a fruits component. Nest the two components inside, first non-citrus, then citrus. Both of these are provided for you behind the scenes. Nest the fruits class component into types of food component below the H1 heading and above vegetables. The result should be a series of nested components. That's a lot of words, but let's see, what are they trying to tell us? Nest two components inside of fruits, non-citrus and citrus. So they say these are, we just assume that these are in scope for us. We don't see them anywhere, but we just assume they're in scope. And then we can add citrus. And then next, fruits put into the types of food beside vegetables. And that's when we start to see it rendered, because we had put these in here, but we hadn't seen them rendered yet because we hadn't rendered fruits inside of types of food yet. So now we're seeing everything. You may remember using the React DOM API in an earlier challenge to render JSX to the DOM. The process for rendering React components will look very similar. The past few challenges have focused on components and composition, so the rendering was done for you behind the scenes. However, none of the React code you'll write will render to the DOM without making a call to React DOM API. Here's a refresher on the syntax. React DOM.render, component to render, target node. The first argument is the component, the second is the DOM node. React components are passed into render a little differently than JSX elements. That's confusing. Aren't React components JSX elements in a way? For JSX elements, you pass in the name of the element that you want to render. However, for React components, you need to use the same syntax as if you were rendering a nested component. Okay, I see what they're saying. So you will use the syntax for both ES6. This has actually caused errors for me before, so this is good that they're mentioning this. Both the fruits and vegetables components are defined for you behind the scenes. Render both as children of types of food, then render types of food to the DOM. There's a div with ID challenge node available for you to use. So below this line, they want us to React DOM.render, and they want us to render the document.getElementById as the second argument. So it's just saying, put my React stuff inside of the challenge node element, and we want to pass we can't just do the name like types of food, like as if it were a JSX variable, but we need to actually render the component as JSX. So the reason for that is this now is JSX. This is just the name of a component. It's just the name of a component, but we actually need to turn it into JSX by, this is kind of like invoking it or running it or declaring it. Oops, we need to put fruits and vegetables down here. And there we go. Now that you've learned the basics of JSX and React components, it's time to write a component of your own. React components are the core building blocks of React applications, so it's important to become very familiar with writing them. Remember, a typical React component is an ES6 class which extends React.component. It has a render method that returns HTML from JSX or null. This is the basic form of a React component. Once you understand this well, you'll be prepared to start building more complex React projects. Define a class component called myComponent that extends React.component. So we'll say class myComponent extends React.component, and this is just standard JavaScript syntax to point that out. It's render method, so we have a render. This is how you do methods in JavaScript. Render method. No, we don't have the word method. We don't have the word function. And then in the render method, we should return a div. And so this is JSX now. It looks like HTML, but it's JSX. And it should contain an h1 tag with the text. So we're going to return an h1 tag with the text, my first React component, and use this text. Make sure to call the constructor for your component too. So let's see if we can remember that. We call like constructor, something like this, and it's going to take props as a parameter. We were supposed to call super on props, I think. And render this using the render method. So we'll do react dom.render. Really getting good at typing document.getElement.byId, huh? And do you see the mistake? Can't pass in just the name of the component. You actually have to wrap that and actually invoke that or declare that you want JSX to happen here rather than just the idea of JSX. This is like a blueprint for the JSX. This is the actual JSX. The previous challenges covered a lot about creating and composing JSX, functional components, and class style components. With this foundation, we can look at props. You can pass props or properties to child components. Say you have an app and it renders a child called welcome, which is stateless. You can pass welcome a user property by writing app with welcome and passing in what looks like an HTML attribute called user, but is technically a prop with the value of mark in single quotes. You can use custom HTML attributes created by you and supported by React to be passed to the component. In this case, the created property user is passed to welcome. Since welcome is stateless functional component, it has access to this value like so. Welcome is a function that takes props and renders props.user inside of an h1. This is a standard call to value props. Standard to call this value props when dealing with stateless functional components. So you can technically name this whatever you want. Props is convention. You basically consider it as an argument to a function which returns JSX. You can access the value of the argument inside the function body. With class components, you will see this a little different. Where there are calendar and current date components in the code editor, when rendering current date from calendar, pass the property date assigned to the current date from JavaScript's date object, then access the prop in the current date showing its value within the p tags. Note that the for prop values to be evaluated, they must be enclosed in curly braces. For instance, date equals open curly brace date, open paren, close curly brace. So let's see, that's a lot of words. When rendering this, when rendering current date from calendar. So calendar, current date, pass in a prop of date equals, and then give the current date. I think the default when you call date, the date function is the current date, and then access it in current date. The current date is props.date. There we go. The last challenge demonstrated how to pass information from a parent component to a child using props or properties. This challenge looks at how arrays can be passed as props. So here colors are passed as the array red, green, blue, and red. The child component then can access them, and array methods such as join could be used when accessing the property. This call will join all the colors into a comma-separated string. Makes sense. There are list and to-do components in the code editor. When rendering each list, so to-do, when rendering each list, from the to-do, pass a tasks property, for example, this, then access this tasks in the list component, showing its value within the element by using join. To display the props.tasks in the P. So props.tasks.join, comma, space. The second list component for tomorrow should have 3 or more items. Is that enough dog walking? React also has an option to set default props. You can assign default props to a component as a property on the component itself. Wow, a lot of words. Default props, my component.default props equals something. You have defined a location prop that's set to the string San Francisco unless you specify otherwise. So that can be overridden. React assigns default props, but if you pass null, it will remain. React defines default props if they're undefined, but if you pass null, it will remain null. The code editor shows a shopping cart component. Define default props on this, which specify that the prop items should have the value 0. So they want us to do shopping cart dot default props. I've never done this. Equals, never done it this way at least. The value 0. Oops, so it has to be an object where items is 0. The ability to set default props is useful. The way to override it is to explicitly set the props. The shopping cart now renders a child items. This items has a default quantity of 0. Override by passing 10 to quantity. Remember, the syntax looks similar. Yeah, I know that. So default props are 0, but instead we want to pass quantity equals 10. Yeah, so they're saying in HTML, numbers might go in as quotes as a string, but since JSX can handle JavaScript objects, of which a number is one, then this is fine to do this way. You can actually just pass a number like that. React provides type checking to verify components receive props to the correct type. Your application makes an API call to retrieve data, and you would expect it to be in an array, which is passed to a component. You can set prop types on your components to require the data to be of type array. Yeah, you could also use TypeScript for this, or TSX. It's considered best practice to set prop types when you know the type of a prop ahead of time. You can define prop types property for a component the way you define default props. This will check that the props of a given key are present with a given type. Here's an example to require the type function for prop call handle click. So we need prop types.func.isRequired. In the example, prop types.func part checks that handle click is a function. Adding is required tells that handle click is required property for that component. It's not optional. You will see a warning if that prop isn't provided. Notice that func represents function. Among 7 JavaScript primitives, function and boolean are the only 2 that use unusual spelling. Function and boolean written as bool. In addition to the primitive types, there are other types available. For example, you can check that a React element, that a prop is a React element. Refer to the documentation for all the types. As of React 15.5, prop types is imported independently from React like this. Import prop types from prop types. But they're hiding that from you, I assume. Define prop types for the items component to require quantity as a prop and verify it's a number. So we have items. They want us to do items.prop types equals object. The quantity prop should be prop types dot number, I guess. The items component should include a prop types and ensure that that value is a number. Oh, required number, so we need number dot is required. The last several challenges covered the basic ways to pass props to child components. But what if the child component you're passing a prop to is an ES6 class component rather than a stateless functional component? Anytime you refer to a class component within itself, you use the this keyword. To access props within a class component, you preface the code that you use to access it with this. For example, if an ES6 class component has a prop called data, you write this.props.data. Render an instance of welcome component in the app component. Here, give welcome a name prop and assign it a value of string. The value of a string. Within the welcome, access name prop with the strong tags. Within the strong tags. So here they want us in welcome to access this.props.name, and then in this we need to, we need to pass in the props I guess where the props coming from. From this, where they passed into app, I guess. The welcome component should have a prop called name. Okay, what's going on here? So give the welcome property, no. How do we actually create that? In the constructor? Render an instance of the welcome component in the parent component app. Okay, so there's already a welcome component. Oh, we're just supposed to give it any random string. Some name. Do we even need the? We don't even need that. Except for the last challenge, you've been passing props to stateless functional components. These components act like pure functions. They accept props as input and they return the same view every time they're passed the same props. You may be wondering what state is, and the next challenge will cover it in more detail. Before that, here's a review of terminology for components. A stateless functional component is any function, wow, this is a lot of text, is is any function you write which accepts props and returns JSX. A stateless component, on the other hand, is a class that extends React component but does not use internal state. That is confusing. A stateless functional component is a function that accepts props and returns JSX, any function. A stateless component, on the other hand, is a class that extends component but does not use internal state, covered in the next challenge. Finally, a stateful component is a class component that does maintain its own internal state. You may see stateful components referred to simply as components or React components. A common pattern is to try to minimize statefulness and to create stateless functional components wherever possible. This helps you contain state management to a specific area of your application. Yeah, if you don't know a lot about state, this probably is like crazy complicated for you. In turn, this improves the development and maintenance, blah, blah, blah. The code editor has a campsite component that renders camper component as a child. Define the camper component and assign it the default props, name, camperbot, inside the camper component. Render any code that you want, but be sure to have one P element. Okay. Define a camper component. Can be a functional component, right? Function camper. Camper dot, what do we call these? Default props. There's also another way to do this that they didn't tell us that I would normally do. We need to render any code we want. I'm going to choose 1p tag that includes only the name, props.name, which we haven't taken in yet, but we will as a parameter. Finally, define prop types. On the camper component to require the name. Verify its type string. Sorry about that. So we need to define camper dot prop types equals name should be capital P prop types dot string dot, does it need to be required? No, it doesn't say it needs to be required. The camper component should include a prop types which require the name to be type string. Is it react.prop types? Require. There we go. One of the most important topics in React is state. State consists of any data your application needs to know about that can change over time. I don't think that comma is needed there. You want your apps to respond to changes and present an updated UI when necessary. React offers a nice solution for state management of the modern web applications. You create state by declaring a state property on the class component in its constructor. This initializes the component with state when it's created. The state property must be set to a JavaScript object. Declaring it looks like this. This.state equals open close curly braces. You have access to the state object through the life of your component, and you can update it, render it in your UI, and pass it as props to child components. The state object can be as complex or simple as it needs to be. Note that you must create a class component by extending React component in order to create state like this. There's a component in the code editor that's trying to render a first name property from its state. However, there's no state defined. Initialize the component with state in the constructor and assign your name to a property of first name. So it's saying, say this dot state equals a JavaScript object where first name is equal to Nicholas. Once you define a component's initial state, you can display any part of it in the UI that is rendered. If a component is stateful, it'll always have access to the data in state and in its render method. You can access the data with this.state. If you want to access a state value within the return of the render method, you have to enclose the value in curly braces. A lot of words. State is one of the most powerful features of components in React. It allows you to track important data in your app and render a UI in response to changes in this data. If your data changes, your UI will change. React uses what's called a virtual DOM to keep track of changes behind the scenes. When data updates, it triggers a re-render of the components using that data, including child components that receive the data as a prop. React updates the actual DOM, but only when necessary. This means you don't have to worry about changing the DOM. You simply declare what you want the UI to look like. Note that if you make a component stateful, no other components are aware of its state. Its state is completely encapsulated or local to that component, unless you pass the state data to child components as props. The notion of encapsulated state is important because it allows you to write certain logic and have that logic contained and isolated in one place of your code. In the code editor, my component is already stateful. Define an h1 tag in the render method which renders the value of name from the component state. The h1 should only render the value from state and nothing else. In JSX, you do this with curly braces to treat it as JavaScript. So access the value from state. Okay, so they want us to render nothing else except for this dot state dot name. Oh, the h1 element. Define an h1 element. There's another way to access state using the render method before the return statement. You can write JavaScript directly. For example, you could declare functions, access data from state or props, perform computations, and so on. Then you can assign any data to variables which you have access to in the return statement. In the myComponent render method, define a const called name. In the myComponent method, okay, const called name. Set it equal to the name in the component state, this dot state dot name. Oops, this isn't a class. This isn't a class, so we need it to be inside the render method. Next, render the value in an h1 tag. Remember, you need to use JSX syntax. There we go. The previous challenges covered component state and how to initialize state in the constructor. There's also a way to change the component's state. Change the component state, not just initialize it. React provides a method for updating state called setState. You call setState within your component like this.setState by passing in an object with key value pairs. The keys are your state properties, and the values are your updated state data. For example, if we were storing a username in state and wanted to update it, it would look like this. You might be wondering why you don't do just this.state equals, and it's because React needs to be able to track those changes. So that's the short answer. React expects you to never modify it and always use the state setter. You should also note that React may batch multiple state updates to improve performance. So that means that updates through setState can be asynchronous. What this means is state updates through setState can be asynchronous. There's an alternative syntax for the setState which provides a way around this. This is rarely needed, but it's good to keep in mind. Please consult a React article for further details. There's a button in the code editor with an on-click handler. This handler is triggered when the button receives a click event in the browser and runs handle click defined on my component. Within the handle click, update the component's state using this.setState. Set the name, property, and state equal to the string React Rocks. So they're saying in this button we have an on-click capital C because this is React, this.handleClick, and inside handleClick we want to React.setState, this.setState, and open object. It's called name. I want to change it to React Rocks. Close the object, close the parentheses, put a semicolon, and there we go. In addition to setting and updating the state, you can also define methods for your component class. A class method typically needs to use the this keyword so that it can access properties on the class, such as state and props, inside the scope of the method. There are a few ways to allow your class methods to access this. One common way is to explicitly bind this in the constructor so that this becomes bound to the class method when the component is initialized. Sounding like a lot of words to me. You may have noticed that in the last challenge, this.handleClick equals this.handleClick.bind this for its handleClick in the constructor. Then when you call a function like this.setState, within your class method, this refers to the class and will not be undefined. The this keyword is one of the most confusing aspects of JavaScript, but it plays an important role in React. Although its behavior is totally normal, these lessons aren't the place for an in-depth review of this, so please refer to other lessons if the above is confusing. The code editor has a component with state that keeps track of the text. It also has a method which allows you to set the text you clicked. However, the method doesn't work because it's using the this keyword that is undefined. Fix it by explicitly binding this to the handleClick method in the component's constructor. Next, add a click handler to the button. Okay, let's take things one at a time. So it's saying we can do this.handleClick equals this.handleClick.bind this. This.handleClick equals this.handleClick.bind this. So in the constructor, we have a method. So even though this is out of order, even though the method is below, the class is going to be able to access the method for the this. So in the constructor, we're making a new instance of an object, which we call this. So this, we want to say on this instance, put a .handleClick, that is equal to the result of calling this.handleClick.bind this. So what we're saying is when handleClick at the beginning, handleClick is trying to use this.setState. It's trying to use the React components set state, but it doesn't have access to the current instance of the React component object until we bind this in the constructor. So in the constructor, we need to tell handleClick who this is, what is its containing object, who is the instance, the object instance, who this handleClick is on. And so that way, when it says this.setState, it's saying call setState on this instance. If that's confusing, object-oriented programming is sometimes confusing. So we need to explicitly bind, and we need to add a click handler to the button on capital C click equals this.handleClick. So we're not calling the function, we're just saying when you click, call the function with this name. Once complete, you should be able to click the button and see you clicked. You clicked. Sometimes you might need to know the previous state when updating the state. However, state updates may be asynchronous. This means React may batch multiple setState calls into a single update, so you can't rely on the previous value when calculating the next value. So that what they mean is if you're trying to set state using the setState thing, you don't want to call this .state because it might not be up to date. You want to get the most recent state version, whereas the this.state might be an out-of-date version. So what we do instead is pass a function that allows us to access the state and props. So let's say we set this, we have the state 1, then we set state and change it to state 2, and then we really quickly do set state again and change it to state 3. So if state 3 is a function of state 2, meaning like we want to add a b at the end for a string, we want to add a b at the end, and then we want to add another b at the end. We don't want to add a b to the first state, which is still in this .state. We want to add a b to the second state, which might not be in this .state yet, but we can access it by using this function. So this function is going to guarantee that the state passed to the function, this function, as an argument, whatever that state is guaranteed to be the most recent, most up-to-date prior state. So they're saying we should do this instead. This is an example, state arrow, and then we set counter to state.counter plus 1. Note that you should have to wrap the object literal in parentheses, otherwise it thinks it's a block of code. My code has a visibility property which is initialized to false. The render method returns one view if the value of visibility is true and indifferent if it's false. Currently there's no way of updating visibility in the component's state. The value should toggle back and forth between true and false. There's a click handler on the button which triggers a class method called toggle visibility. So that is, where's toggle visibility? Toggle visibility, I don't see it defined anywhere. Pass a function to setState to define this method so that the state of visibility toggles to the opposite value when the method is called. Visibility is false, the method sets it to true, and vice versa. Finally, click the button to see the conditional rendering of the component based on its state. Alright, what are they even trying to get us to do? So they want us to make a this.toggle visibility function where we're setting that equal, no, they want us to make a toggle visibility method, and on that they want us to use the this keyword. We'll just leave that for now. And then they want us to, in the constructor, make sure that the toggle visibility method knows that who its this is. So we're going to do toggle visibility.bind this, and then in toggle visibility we're going to call this .set state, and it should just, if visibility is false, it should take the state, so this .state essentially, but remember we want to get it from the callback function instead. So we could just put this right in line like they did, but to make it less confusing, I'm going to make my own little arrow function. So const setter equals take in a state object, which is the most recent value of this .state, and give me back a new state object where visibility is equal to the opposite of visibility, so not visibility. And where is it going to get visibility? From this state parameter, so not state.visibility. And because it's an arrow function, we need to wrap this object literal in parentheses and put a semicolon at the end. And then we're going to pass this setter to set state and put a semicolon. now we need to, an anonymous function should be passed to set state. Well, maybe they want us to pass it directly like this, so I'm just going to replace that and see if they like it better. There we go. You can design a more complex stateful component by combining the concepts covered so far. These include initializing state, writing methods that set state, and assigning click handlers to trigger these methods. The counter component keeps track of a count value in the state. There are two buttons which call methods increment and decrement. Write these methods so that the counter value is incremented or decremented by 1 when the appropriate button is clicked. Also, create a reset method so that when the reset button is clicked, the count is set to 0. Make sure you don't modify the class name of the buttons. Also, remember to add the necessary bindings for the newly created methods in the constructor. Yeah, so some of these things you would not have to do if you used function components, but I'll just ignore that for now. So we need to have an increment and a decrement. Increment, and we're going to need a decrement. And these lines of code are wrong so far, but I'm just going to throw these in here so I have the text. We're going to need an increment, a decrement, and a reset. So these are going to be methods, so open paren, like that, open and close paren, open and close curly brace, and then this dot increment, decrement, and whoops, forgot reset, and reset is going to be this dot increment equals this dot increment dot bind this. So that's going to make sure that increment knows who its this is when it uses this inside of itself. And we're going to follow that same format for the other two, so that when we're inside of here, we can increment and decrement. What does that actually mean in the context of this? So they want us to do an increment, a decrement, and a reset. And our current count is 0, and our count is held inside of state, which is an object. So let's see if they'll let me do it without an anonymous function, because I like setters. Const setter, or you could even technically do function setter. Function setter takes since state, or I really like the name prev state, prev or prev state, because it signifies to me that this is the previous value of the state. And then I could even take out count and assign it to the name prev count. This is just JavaScript syntax. If you're not familiar, I'm just naming, I'm pulling out count from whatever object. I'm taking prev and deconstructing it so that I assign count to the name prev count, because I'm going to use count again. Actually, I don't need to do that. I could just take it out as count. So I'm pulling out count from prev, and then I'm going to return a new object where count is added. Let's call it let, so we can increment it. So let count equals the count from prev, and then we will count plus plus, and then we will return the object with the new count variable in there, and we will pass this to this dot set state setter. Hopefully they'll let me use function syntax, because I like to do it this way. It's cleaner for my understanding. Oh no. Okay. And in decrement, we just need to minus minus decrement. And in reset, we just need to, we don't even care about the previous state, so we don't even need to use a function. We can just set state to count 0. And before I move on, I'll just show you increment, decrement, decrement, reset. Increment, decrement, reset. So I didn't have to use a setter here because I didn't really care about the previous value, whereas in this one I needed the previous value. I couldn't settle for the second to last value. I needed the exact previous value of state. Your application may have more complex interactions between state and the rendered UI. For example, form control elements for text inputs such as input and text area maintain their own state in the DOM as user types. With React, you can move this mutable state into a React component state. The user's input becomes part of the application state so that React controls the value of the input field. Typically, if you have React components with input fields the user can type into, it will be a controlled input form. The code editor has the skeleton of a component called controlled input to create a controlled input element. The component state is already initialized with input property that holds an empty string. This value represents the text the user types into the input field. First, create a method called handleChange that has a parameter called event. When the method is called, it receives an event object that contains a string with the text input, and you can access it with event.target.value inside the method. Update the input property of the component state with the new string. A lot of text. In render method, create input element above the h4, add a value attribute which is equal to the input. I'm already overwhelmed. First, create a method called handleChange that has a parameter called event. There we go. When the method is called, it receives an event object and contains the text from the input. You can access this with event.target.value. So we'll say const value equals event.target. So I'm saying destructure event.target, which has a value property and can give me the local variable value inside of this. Update the input property of the component state with this new string. So we don't care about the previous value, so we can just do this dot set state, and we don't need to pass a function. We can just pass the value. The value, but we need it to be for the input property of that. So right now it might be an empty string and we want it to be the new value instead. Or a little trick, we could even, without having to rename this, we could call this, just say input, which is basically the same as input : input. And then we can get that local variable name by renaming this. Say take the value property out of event.target and then rename it to input. Nice little trick there. Keep your code nice and concise. Maybe harder to read if you don't know this, but more concise. You can access the string, update the thing with the state, render, in the render method create the input. So since we're using this, remember we have to bind this.handleChange to say this.handleChange dot bind this, and then when you type in the input box, the text is processed by handleChange, set the input property of the local state. This just, I don't know why, but this just makes no sense to me. When you type in the input box, that text is processed by the handleChange method. Did they even tell us to make an input? It has a skeleton to create a controlled input. The state is already initialized. The value represents. I guess they want us to put the input here. Oops, so we have this.state. I made a mistake. It's coming out as object. We don't want this.state. We want this.state.input. At least wait, what happened? What happened here? This does state.input. Got my cursor confused. And close this out. So now we can try to type in here, but nothing's going to happen because we're fixed at an empty string. So we need to say on change equals this dot handle change. Now we can change. The last challenge showed that React can control the internal state for certain elements like input and text area, which makes them controlled components. This applies to other form elements as well, including regular HTML form element. My form is a component set up with a form with a submit handler. The submit handler will be called when the form is submitted. We've added a button which submits the form. You can see it has type submit. So they're talking about this. So that means it's going to automatically submit its containing form. That's an HTML thing. Add an input element into the form and set its value and on change. Our state variables are called input for this. This.state.input on change equals this dot handle change. Okay, we can change that. And you should complete the handle submit so that it sets the component state. So they already did the binding for us. It needs to set the component state property submit to the current value in the local state. So I think they want us to set submit to the entire value of the current state, which would be that. It seems odd. It sets the component state property. Okay, so this dot set state sets the component state property. Submit, just the submit one, to the current input value in the local state. Okay, so we're going to probably need to do the setter method because we need the current state. So function setter prev state. We need to say, I think we can edit a parameter. This is a variable in our current scope. I think we can edit this directly. Prev state dot submit equals prev state dot input. Is that what they're trying to go for? To the current input value in the local state. Yep. And say return prev state. Another way you could do this would be like new state equals spread, meaning give me all the contents of, throw away the curly braces and then throw them back on. It's kind of like a way to copy the object, prev state, but then we could change prev state, or we could change the submit property to be input. Like that. And I think this would also work. But anyway, we'll just do this. And we have to do event.prevent default to prevent the form submit behavior, which reloads the page. And it's been disabled here to prevent refreshes. Finally, create an h1 tag after the form, which renders the submit value from the component state. So I think we should have put our input inside of the form, if you noticed that earlier when I missed that. And we need to have an H1 that now contains the value from this.state.submit. Doesn't seem to be working. Submitting the form should run handle submit, which should set the submit property in state equal to the current input. Brief state.submit. Oh, didn't pass the setter. Yep, and it worked. And let's see if we can do the other new state method where this essentially says take prev state and spread it, meaning drop its object's curly braces. So just give me all the contents, give me all the key value pairs. So we have the input is something and the submit is something, and then we're going to say, hey, we already defined submit, but let's redefine submit as something different. So that's going to override submit's previous value to whatever we say, which is prev state.input, and then we're setting this entire thing is going to be an object called new state, and so we're returning that. So actually we could literally just do this, return a one-liner, and it's going to do the same thing. So we put that, we hit submit, and it turns into an H1. You saw a lot of examples that passed props to child JSX and child React components in previous challenges. You may be wondering where those props come from. A common pattern is to have stateful component containing the state important to your app and then render a child component. You want these state components to have access to some pieces of that state which are passed as props. For example, you may have an app component that renders a navbar among other things. Your app has state, but the navbar only needs access to the username. So you pass just that piece of state to the navbar. This pattern illustrates some important paradigms. The unidirectional data flow. Yeah, this isn't strictly true because you can also pass data to parents in a certain way, but it's not the general paradigm. State flows in one direction down the tree in your application's components from stateful parent components to child components. The child components only receive the state data they need. The second is that complex stateful apps can be broken down into just a few or maybe a single stateful component. The rest of your components can simply receive state from the parent as props and render a UI from that state. It begins to create a separation where state management is handled in one part of code and UI rendering in another. This is a principle of separating logic from UI, and it's one of React's key principles. When used correctly, it makes the design of complex stateful applications much easier to manage. The MyApp component is stateful and renders a navbar component as a child. Pass the name property in its state down to the child component. So we're saying give navbar a prop called name and give the value this.props.name. Then show the name in the h1 tag that's part of the navbar. The name should appear after hello my name is, so it's going to be called this.props.name. The navbar should receive the MyApp state property as state property name as props. Thought that's what I did. The MyApp component is stateful, right? Oh, not this.props.name, this.state.name. You can pass state as props to child components, but you're not limited to passing data. You can also pass handler functions or any method that's defined on a React component to a child component. This is how you allow child components to interact with their parent components. You pass methods to a child just like a regular prop. It's assigned a name, and you have access to that method under its this.props in the child component. There are three components outlined in the editor. The MyApp component is the parent that will render the getInput and renderInput child components. Add the getInput component to the render method in MyApp. Then pass it a prop called input, assign input value from MyApp state. Also create a prop called handleChange and pass the input handler handleChange to it. That's a lot of words for me. So there are three components: MyApp, parent renders getInput and render input. Add the getInput component to the render method in MyApp. All right, I can do that. Add getInput to the render method. Got it. Then pass it a prop called input. Input equals. Assign it the value of input value from MyApp state. So that'll be this.state.input value. Also create a prop called handleChange and pass the input handler handleChange to it. HandleChange equals this.handleChange. And that's just wrapping around, but it's on the same line. Next, add renderInput to the render method in MyApp. That would be this one. Then create a prop called input, been there, and pass it the input value from state, also been there. Once you're finished, you'll be able to type in the input field in the getInput, which calls the handler method. This updates the state, which is passed as props. Observe how the data flows between the components. And the single source of truth is in this parent component, MyApp. And there we go. GetInput, we have the values in here, and then it's living in MyApp, so therefore it can be passed and changed by getInput, but then it can also be passed to renderInput. React components have several special methods that provide opportunities to perform actions at specific points in the lifecycle of a component. These are called lifecycle methods or lifecycle hooks and allow you to catch components at certain points in time. This can be done before they are rendered, before they update, or before they receive props, before they unmount, and so on. Here's a list of the main lifecycle methods. Component will mount, component did mount, component should component update, component did update, component will unmount. The next several lessons will cover some of the basic cases for these lifecycle methods. Note, component will mount lifecycle method will be deprecated in a future version of 16.x and removed in version 17. In the current day, we're at version 19, so do the math on that one. Component will mount is called before render when a component is being mounted in the DOM. Log something in the console when you do component will mount. You might want to have your browser console window. They used to be able to show us this, but oh no, they don't need it. They show us the console. Most web developers at some point need to call an API endpoint to retrieve data. If you're working with React, it's important to know where to perform this action. The best practice with React is to place API calls or any calls to your server in the lifecycle method component did mount. This is called after a component is mounted to DOM. Any calls to set state here will trigger re-rendering of your component. When you call an API in this method, your set state with the data that the API returns will automatically trigger an update once you receive the data. There's a mock API call in component did update. It sets state after 2.5 seconds to simulate calling a server to get data. This example requests the current total active users for a site in the render method. Render the value of active users in the H1 after the text this. Okay, active users. So we want this no, is it this dot state, because we're in the same component, dot active users. And watch what happens in the preview. Yeah, so it's changing because after 2.5 seconds that happened. Component did mount is also the best place to attach event listeners you need for specific functionality. React provides a synthetic event system which wraps the native event system present in the browsers. This means the same synthetic event system behaves exactly the same. No, it means the synthetic system behaves exactly the same regardless of the user's browser, even if the native events may behave differently. You've already been using some such as onClick. React's synthetic system is great for most interactions for the DOM elements. However, if you want to attach an event handler to the document or window objects, you'll have to do this directly. Attach an event listener in the component did mount for key down events and have these events trigger the callback handle key press, so you can use document.add event listener, which takes in quotes as the first argument and the callback as the second argument. Attach an event listener in component did mount for key down. So we want to look and say add a listener for the event called key down and pass it a handler, which we're going to say handle key press is the name of the handler, but it's a method, so it's this dot handle key press. Then remove the same event listener in unmount. So far, if any component receives new state or props, it re-renders itself and all its children. This is usually okay, but React provides lifecycle methods you can call when components receive new state or props and declare specifically if the components should update or not. The method is shouldComponentUpdate, and it takes next props and next state as parameters. This method is a useful way to optimize for performance. For example, the default behavior is that your component re-renders when it receives new props, even if the props haven't changed. You can use shouldComponentUpdate to prevent this by comparing the props. The method must return a Boolean value that tells React whether or not to update the component. You can compare the current props, this.props, to the next props to determine if you need to update or not, and return true or false accordingly. So, getting a bit bogged down in the words here, but React provides a method we can call when new state or props come through and declare specifically whether the components should update. So it takes next props and next state, and we can return true if we want to re-render and false if not. ShouldComponentUpdate is added in a component called onlyEvens. Currently it returns true, and it re-renders every time. Modify it so that it updates only if the value of the new props is even. So props.value is even. So we want to know if next props.value mod 2. So the remainder when dividing by 2, if that is equals triple equals to 0. There are other complex concepts that add powerful capabilities to your React code, but you may be wondering about a more simple problem: how to style those JSX elements you created. You'll likely know that it won't be the same as working with HTML because the way you apply classes to JSX elements. If you import styles, it isn't much different at all. You apply a class to your JSX using class name and apply styles to the to the class in your style sheet. Another common way is to do inline styles, which are very common in React.js development. You apply inline styles similar to how you do it in HTML, but with a few differences. Here's an example of an inline style. That looks pretty similar to HTML. JSX elements use style attribute. Because of the transpilation, you can't set the value to a string. Okay, so you can't do this. You set it equal to a JavaScript object, like that. Notice how we use camel case for font size, even though in CSS it would have kebab case, which is dashes between them. React doesn't accept kebab case because it's not valid JavaScript. Add style attribute to the div and give the text a color of red and a font size of 72 pixels. So we can optionally set the font size to be a number by omitting the pixels or write it as 72 pixels. So I prefer the pixels way because it's more explicit what's going on. So we'll say style equals, and we need one set of braces for saying, hey, we want to do JavaScript, and then one set of braces for the actual object of the style. Then we want to say color key should be equal to red, comma, the font size, camel case, should be equal to 72px. You may have noticed in the last challenge there were several other syntactic differences from HTML inline styles in addition to the style attribute to set a JavaScript object. First, the names of certain CSS style properties can use camel case. For example, the last challenge was font size instead of font dash size. Hyphenated words are invalid for JavaScript, so React uses camel case. All property value length units like height, width, font size are assumed to be in pixel unless otherwise specified. If you want to use M, you need to wrap it in quotes, like font size 4M in quotes. Other than the length values that default to px, all other property values should be wrapped in quotes. If you have a large set of styles, you can assign a style object to a constant to keep your code organized. Declare your styles as a constant global variable at the top of the file. So const styles equals, and then initialize an object with 3 style properties and their values to it. Doesn't say what, does it? Oh, div, give the div a color of purple. They say color, I don't know if they mean the font color or the background color, but we'll just say purple. And, oops, not semicolon, but comma, because it's a JavaScript object. And give it a font size of, we can do 40, that means 40 pixels, and a border of 2 pixels solid purple. This is a shorthand string for a couple of border properties in CSS. So this is all CSS except for the casing here and the fact that this is turned into an object, but the keys and values here are just CSS. Then set the style attribute equal to the styles yeah, okay. So div styles equals style equals styles. Previous challenges, you learned how to inject JavaScript into JSX with curly braces for tasks like accessing props, passing props, accessing state, inserting comments into your code, and most recently styling your components. These are all common use cases to put JS in JSX, but they aren't the only ways. You can also write JavaScript directly in your render methods before the return statement without inserting it inside of curly braces. This is because it's not yet within the JSX code. When you want to return, yeah, they already told us this. When you want to return, want to use a variable later in the JSX code inside the return statement, then you need it in curly braces. The code in render has an array that contains 20 phrases to represent answers found in a stupid toy from the 80s. The button click is bound to the ask method, so each time the button is clicked, a random number will be generated and stored as random index in state. On line 52, delete the string change me and reassign it the answer const so that your code randomly accesses a different index. Wait, reassign the answer so that it randomly accesses a different index. How do we do that? Are we supposed to write that randomness, or does that come in here somewhere? So that it accesses a different index each time. Finally, insert the answer const inside of the p tags. So what are we supposed to do here? I get the idea, but this is setting state. Oh, okay, we're supposed to get it from state. So the random index, possible answers is here. We need to get the random index from state. And has ask been called for the first time? Because at the beginning it's going to be this empty string. So I don't like that. I want it to be this. So say this.state.randomIndex. And that is going to be what we use to access. Oh, wait. No. That's going to be what we use to access from the possible answers array. Is that what they want? No. They want us to use the answer, reassign it, and then insert the answer inside the p tags. See what this even does. Okay, fine. Oh, so ask gets called when we press the button, so that's why it's not a problem that it's not set to begin with. Another application of using JS is to control your rendered view by tying the elements that are rendered to a condition. When the condition's true, one thing renders. When it's false, another. You can do this with a standard if-else. My component contains a boolean in its state which tracks whether you want to display some UI or not. The button toggles the state of this value. Doesn't do anything yet. Currently it renders the same UI every time. Rewrite the render method. That would be this. So that if display is true, you return the current markup. Otherwise, return the markup without the h1 element. So they're basically saying, in one case, return this, and then in another case, return it without the h1 element. So what I would normally do is probably not the most understandable thing. So let me show you what is most understandable. Most understandable is we just do simple if this dot state dot display comes. I know that because it's up here. This dot state dot display. Then we want to return like normal. If not, remember we could do an else here, but we don't need to do an else because this is going to short circuit if this is true. So if we get down here, it means it's false. Then we can just get rid of that. And when display is set to false, only a div and a button. Yep. The render method should use an if-else statement. Okay, so they do want us to use this, if-else. This is not how most React developers would do this. Only a div and a button should be displayed. Yep, that's what I'm doing. Yep, Okay, they didn't like my comment. So let me just tell you what I would normally do. This is very wordy and it has duplicated JSX, which is pretty bad form. So I'm going to copy this so I can pass the tests, but I'm going to go back. What we would normally do would be something like we would use the JavaScript ternary operator. Ternary means we're going to say if state.display this.state.display, if that's true, so question mark, is that true? If that's true, then do this. Otherwise, do nothing. But they're not going to like this answer. So I'm just going to paste back what I had. And we have an ad. Getting close. Hour and 45 minutes. Not too bad. About almost 85% done. When are we going to get to some function components? The if-else statements worked in the last challenge, but there's a more concise way to achieve the same result. Oh, look at that. They're using something more concise. You can use the logical ampersand logical operator to perform conditional logic in a more concise way. This is because you want to check if a condition is true, and if it is, return some markup. Here's an example. Condition and markup. Yes, the reason this works is because this expression will evaluate to, if this evaluates to false, and is going to say, don't even look at the next thing. We know it's false. And false is a falsy value, which is, I guess, kind of resolves to the JSX of null. If the condition is true, then the markup will be returned. If the condition is false, the operation will immediately return false. Yeah, that's what I said. You can include these directly in your JSX. This allows you to handle more complex logic. So they just want us to change this to be, I guess their way was even better than the ternary operator, but let's see if they teach us that next. This.state.display and h1. So if this is false, it's going to stop there. If it's true, it's going to give us this. I think the reason that works is because perhaps in JavaScript, when you evaluate a logical statement like this, it's going to keep going until something is false. And so if it's false, it's going to return false. But if it's true, I think it just returns the last thing. So that would be this. Or it may just be a JSX specific thing. Before moving on, there's one last way to use JS conditionals to render what you want, the ternary operator. Oh my gosh. Yeah, so I don't want to read all this because hopefully there's nothing that useful in there. And they want users to have a way to interact with a component within its return statement, which set up a ternary expression with the logic. When the page first loads, render the submit button 1. Okay, and then when it enters their age and clicks the button, render a different button based on the age. If they enter something less than it, 18, do button 3, greater than 8 or equal to 18, do button 2. So we're going to use multiple ternary operators, I think. So we're going to say first Boolean to evaluate is going to be when the page first loads, render the submit button. Okay, so user.age is the empty string. So state, this.state.userAge, this.state.userAge, and because we're going to type this so many times, I'm just going to put this into a variable up here. Const age equals equals this.state.userAge, and then we're going to say age. We can even do this up here to make it cleaner. We can say const adult is equal to age is greater than or equal to 18. Const child equals age is less than 18, also known as not adult. And when the user first when the page loads, we want to do button 1. So const first load is when age is the empty string, which is the default value. So we're going to say first load question mark. If it's the first load, then give us button 1. Button 1. Otherwise, ask a new question. If it is a child, then ask if it's a child, and if it's a child, then do button 3, and otherwise it's an adult, so do button 2. So first load, is that true? Then button 1. Okay, otherwise child, question mark? If so, button 3, otherwise button 2. Uh-oh. The check user age component should render with a single input element and a single button element. What did we do? Probably an issue of not reading the instructions. The component should render with a single input element and a single button. Oh, and a single button. Oh yeah, that's what I did. Type error, cannot find user age. Change code below this line. I guess they didn't initialize. So handle change sets the input value in the state. I guess we didn't initialize the state at all. First initialize the state of check user age. Yep, so I didn't do that. Both being empty strings. Alright, here we go. Let's see. 5, submit. You shall not pass. 44. You may enter. So far, you've seen how if else and the ternary and the ternary operator condition question mark expression if true colon expression if false to make conditional decisions about what to render and when. However, there's one important topic left that lets you combine any or all of these concepts with another powerful feature, props. Using props to conditionally render code is very common with React developers. They use the value of a given prop to automatically make decisions about what to render. In this challenge, you'll set up a child component to make rendering decisions based on your props. You'll also use the ternary operator, but you can see how several of the other concepts that were covered in the last few challenges might be useful in this context. The code editor has two components that are partially defined for you. A parent called game of chance and a child called results. They are used to create a simple game where the user presses a button to see if they win or lose. First, you need a simple expression that randomly returns a different value every time it's run. You can use math.random. This method returns a value between 0 inclusive and 1 exclusive each time it's called. So for 50-50 odds, use math random greater than or equal to 0.5 in your expression. Statistically speaking, this expression will return true 50% of the time and false the other. In the render method, replace null with the above expression to complete the variable declaration. Now you have an expression that you can use to make a randomized decision in code. Next, implement this. Render results component as a child of game of chance. And pass expression as a prop called 50-50. In the results component, write a ternary expression to render the H1 with the text you win or you lose based on the 50-50. Prop. So ask this.props.50-50 if that expression is true, then you win, otherwise you lose. Finally, make sure the handle click method is correctly counting each turn so the user knows how many times they've played. Counter should be prev state dot counter plus plus. Counter plus 1, let's say. At this point, you've seen several applications of conditional rendering and the use of inline styles. One more example that combines both. You can also render CSS conditionally based on the state of React component. To do this, you check for a condition, and if that condition is met, you modify the styles object that's assigned to the JSX elements in the render method. This paradigm is important because it's a dramatic shift from the more traditional approach of styling by modifying DOM elements directly, which is very common with jQuery, for example. In that approach, you must keep track of when elements change and also handle the actual manipulation directly. It can become difficult to keep track of changes, potentially making your UI unpredictable. When you set a style object based on a condition, you describe how the UI should look as a function of the application's state. There's a clear flow of information that only moves in one direction. This is the preferred method when writing applications with React. The code editor has a simple controlled input component with a styled border. You want the styled border red if the user types more than 15 characters of text. Add a condition to check for this, and if the condition is valid, set the input border style to 3 pixels solid red. You can try it out before entering text in the input. The code editor has a simple controlled input when the user types more than 15 characters. Okay, so when the user types more than 15 characters, meaning that this dot state dot input, which is a string, dot length is greater than 15, I'm going to call that long is long. Add a condition to check for this, and if it's valid, set the border style. The input style's there. I'm going to say border input style dot border equals this. And input style dot border we don't need it that always, we just need it that is long we change it to that, otherwise we can use the existing value. Conditional rendering is useful, but you may need your components to render an unknown number of elements. Often in reactive programming, a programmer has no way to know what the state of an application is until runtime, because so much depends on the user's interaction with the program. Programmers need to write the code correctly to handle unknown state ahead of time. Using array.map in React illustrates this concept. For example, you can create a to-do list app. As the programmer, you have no way of knowing how many items might be on the list. You need to set up your component dynamically to render the correct number of elements long before someone using the program decides that today is laundry day. The code editor has most of the to-do list components set up. Some of this code should look familiar to you if you've completed the controlled form challenge. Notice a text area and a button along with a couple of methods that track their states. Inside the constructor, create a this.state object and define two states. User input should be initialized as an empty string. And to-do list should be initialized as an empty array. Next, delete the null value in the render next to the items variable. In its place, map over the to-do list array stored in the component's internal state. And dynamically render an li for each item. Try entering the string eat, code, sleep, repeat into the text area, and then click the button to see what happens. So we're using map to go over the array. This is just basic JavaScript, so if you're not familiar with the map function, this is a way to iterate over the to-do list and this function will return, or this method will return a changed version of the array where we have taken in the element, the current array element at each spot, and we have changed it to be something different. So in this case, we want to change the elements to, we want to change the string elements in the to-do list to be JSX, that is list items, where we render the element, or really it's like a TDL, a to-do list item, TLI. And there it goes. The last challenge showed you how to map use the map method to dynamically render a number of elements based on user input. However, there was an important piece missing. When you create an array of elements, each one needs a key attribute to set a unique value. React uses these keys to keep track of which items are added, changed, or removed. This helps make the re-rendering process more efficient when the list is modified in any way. Note that keys are only needing to be unique between sibling elements. They don't need to be globally unique in your application. So what that means is you could use like the index or a transformation of the index of the current element to be your key. The code editor has an array with some front-end frameworks and stateless functional component named frameworks. Frameworks needs to map the array to an unordered list, much like the last challenge. Finish writing map to return li element for each framework in the front-end frameworks array. This time, make sure to give each li a key attribute and set to a unique value. The li elements should also contain text from front-end frameworks. Normally, you would want to make the key something that uniquely identifies the element being rendered. As a last resort, the array index may be used, but typically you should only try to use a unique identification. Yeah, the reason you wouldn't want to use an index, like you can use a transformation of the index, but it's not preferred because, for example, if you had like a drag and drop list, the people can reorder the list items, and so it's okay if it's I guess it might work if it's transformation of the index, but if it's the active index could change. So I think actually even if it's a transformation, that could cause a problem. So it'll create a very specific bug that's I've had before, and it's hard to debug. So what are we doing? Finish writing the map callback to return an li for each framework in the front-end frameworks. So here there should be front-end frameworks dot map, and to clean this up, I'm going to say render one li, and so this is going to say const render one li is going to be take a framework string and return to me in parentheses an li and make the contents that. But they also want us to add a key, and in this case it's okay to use the value itself as the key, because let's say we had a drag and drop list, and even if we moved React to be where Ember is now, the index would change and a transformation of the index would change because React is reactive. But not this text React, but the framework React is reactive. If I moved Ember to where Knockout is, the index would update. So if we pass the index as a key, which we could do, like map can also take, it can take a 1 argument function, it can also take a 2 argument function or a 3 argument function. So for a 2 argument function, the second argument is the index. So if we passed the index into here, if we reorder this, this is going to make it very hard to identify Ember as Ember, because if we move it to position 1, well, React was the one at position 1, so it's just creating confusion as to which thing is which. Whereas if we use, in this case, if we use the value itself, that's going to be maintained even if the position in the array changes. And we could even change this a little bit, like make it a format string and wrap it in curly brace with a $sign and say, key dash this dash react. We don't have to do that, but you could do that. That key can be anything. You just don't want it to be the same thing for each list item. The map array method is a powerful tool, and it'll often work. Another one is filter, which filters the contents based on a condition and returns the new array. For example, if you have an array of users that all have a property online which can be set true or false, you can filter based on only those users that are online by writing something like this: user arrow users.online. So this callback function returns a boolean, and it says keep the item in users when you filter it and you give me a new array, because you're not going to modify users directly. You're going to give me a new users like array, except where any user that is .online false is going to be taken out. In the code editor, my component state is initialized with an array of users. Some are online and some aren't. Filter it so that only those online are showing. To do this, first use filter to return a new array containing only the online ones. Then in the render online variable, map over the filtered array and return an li for each user that contains the text of their username. Be sure to include a unique key as well. So there's our data, this.state.users. This is going to be this.state.users users.filter, and I'm going to say crit for criterion, and const crit, or I could even do function crit. It's going to take a user and it's going to return whether the user is online. And I could even go one step further and destructure that, so that instead of calling it user, I'll just pull out online, which is what I care about, and just return online. So a little easier way to do this would be, instead of just that whole function, just do filter and say open set of parentheses. This is necessary so that we can put a JavaScript object destructuring in there, pull out the online. We don't even care that it's called user because we only need online, and we're going to say arrow to online, the Boolean value, and then render online is going to be this dot state dot users dot no, it's going to be users online dot map render one, which I'm going to name const render one to be take a user and return the user dot username inside of parentheses a list item, so I could say in curly braces user dot online, or sorry, user dot username, because that's what we care about for display. But even like I did up here with this destructuring, I can just do username, and then instead of calling it user, I can just say, let me forget what the name is, I don't care, just pull out the username for me. And we need a /li. There we go. Each should have a key. Whoops. So we need key equals username. So far you've been rendering React components on the client. Normally this is what you'll do. However, there are some use cases where it makes sense to render a React component on the server. Since it's JavaScript view library and you can run JavaScript on the server with Node, this is possible. In fact, React provides render to string method you can use for this purpose. There are two key reasons why rendering on the server may be used in real-world app. First, without doing this, your React apps would consist of a relatively empty HTML file and a large bundle of JavaScript when it's initially loaded into the browser. This may not be ideal for search engines that are trying to index the content of your pages so people can find you. If the initial HTML is sent to the client and the page contains all the markup, and the initial page load contains all of the page's markup, which can be crawled by search engines. Second, this creates faster initial page load experiences because the rendered HTML is smaller than the JavaScript code of the entire app. React will still be able to recognize your app and manage it after the initial load. Yet the downside here is that then you have to have a server running all the time to serve your React app. So that's a different cost, as opposed to if you use it only on the front end, you can create static assets and just give them to a hosting provider. And it does create that performance challenge, but it's easier in terms of hosting for you. The render to string method is provided on React DOM server, which is available here as a global object. The method takes one argument, which is a React element, and use this to render app to a string. I don't know what they want, if they want us to do anything with this string, but okay. And because it's like this, remember we're going to have to pass it in like with those 100% complete. And here's an ad. Okay, so we're 100% complete. We didn't even get into functional components in terms of React hooks and things like that, so that'll be future learning. But thank you for watching. You have gotten through the FreeCodeCamp React front-end